Okay, solving systems and equations, real world problems. So this is a review of solving word problems using systems. Wow, you've learned many different strategies for solving systems of equations. First, we started with graphing systems of equations. Then we moved on to solving systems using substitution method. We used linear combination or the elimination method to solve systems of equations. We also use equal values method. Now we're ready to apply these strategies to solve real world problems. Are you ready? Of course you are. First, let's look at some guidelines for solving real world problems, and then we'll look at a few examples. All right, steps for solving real world problems. So first, highlight the important information in the problem that will help write two equations. Define your variables, decide what x and y are going to equal. Write two separate equations. Use one of the methods for solving systems of equations to solve. Check your answer by substituting your ordered pair into the original equations and answer the questions in the real world problems. Always write your answers in complete sentences. All right, example number 1. It says, you're running a concession stand at a basketball game. You're selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. You must report the number of hot dogs sold and the number of sodas sold. How many hot dogs were sold and how many sodas were sold? All right, let's start by identifying some important information. All right, so something that we know that hot dogs cost $1.50. We know that sodas cost 50 cents. We know that there was a total of $78.50 sold and 87 hot dogs and sodas. All right, so that gives us the information we're going to need. All right, so next it says define your variables. Ask yourself, what am I trying to solve for? What don't I know? In this problem, I don't know how many hot dogs or sodas were sold. So this is what each variable will stand for. Usually the question at the end will give you that information. So let's say we're going to make x equal hot dogs and y equals sodas. And notice that question says how many hot dogs were sold and how many sodas were sold. Those are the two things that we're looking for. Right, two equations. So my first equation is going to have to be with the cost. So I know that each hot dog costs $1.50. So I'm going to do $1.50x plus 50 cents y, and that equaled a total of $78.50. Okay, then my other information is that I sold a total of 87 hot dogs and sodas combined. So then I just do x plus y equals 87. All right, so now I have a choice of which method I want to use to solve. So I can graph it, which is usually not my best choice. I can use elimination method, I can use substitution, or I could use equal values. Since neither one of them is already equal to a variable, equal values isn't the best one. Elimination, I'm not quite sure that would work best, so my best method is probably going to be substitution. So I'm going to use substitution to solve. All right. So I'm going to take that second equation, the x plus y equals 87, and I'm going to rewrite it so it equals y, because that makes the most sense. So that's where I'm going to start. So I'm going to take x plus y equals 87. And then I'm going to rewrite it by subtracting x from both sides as y equals negative x plus 87. So then I'm going to take that and substitute it for y in my other equation. So I have $1.50x plus 0.5 times negative x plus 87 equals 78.50. And then I'm going to solve. Okay, so this ends up being 1x plus 43.50. So then I subtract 43.50 from both sides. So I get x equals 35. Okay. So then I plug it back in. I'm going to use my y equals negative x plus 87 equation. So I'm going to do y equals the opposite of 35 plus 87 to get 52. So my ordered pair is 35, comma 52. All right, so then what does a solution mean? So it means that there were 35 hot dogs, x equals hot dogs, which is 35, and y equals sodas, which was 52. So I answered a complete sentence. So we sold 35 hot dogs and 52 sodas. All right, check your work by substituting. So we should substitute them back into the original equations. So x plus y equals 87 was one of them. And then 1.5x plus 0.5y, 78.50. So 35 plus 52 equals 87. So that one works. And then $1.50 times 35 plus 50 cents times 52 should equal 78.50. So this equals 52.5 plus 26 does equal 78.50. So both of them worked. Example number 2 says you and a friend go to Tacos Galore for lunch. You order 3 soft tacos and 3 burritos, and your total bill is $11.25. Your friend's bill is $10 for 4 soft tacos and 2 burritos. How much do soft tacos, how much do burritos cost? Let's start by identifying the important information. So we know that, so you ordered, say, 3 soft and 3 burritos, and spent $11.25. Your friend ordered 4 soft and 2 burritos, and spent $10. All right, define your variable. So I'm just going to start with x and y. So x is going to equal my soft tacos, and y is going to equal my burritos. Okay, write two equations. So I'm going to do 3x plus 3y is going to equal 1125. And then 4 tacos and 2 burritos, so 4x plus 2y is going to equal 10. So I'm going to choose, because of the way that my equation is set up, I'm going to choose equal elimination method this time. All right, so I'm going to use elimination. Okay, so I start with my equations. I have 3x plus 3y equals 1125. And I have 4x plus 2y equals 10. So I'm going to make my y's equal to each other so that when I subtract, they cancel out. So I'm going to multiply my top equation by 2 and my bottom equation by 3. So now I'm going to have 6x plus 6y equals, I want to say 2250, but let me check my calculator. 2250. And then my bottom equation is going to be 12x plus 6y equals 30. So I'm going to subtract. 6x minus 12x is negative 6x. My y's cancel out. 2250 is negative 750. Then I divide both sides by negative 6. Was $1.25. All right, so now I'm going to plug it back into my original equation. So I'll use the one with 10. So I have 4 times $1.25 plus 2y equals 10. So 4 times $1.25 equals 5. So I have 5 plus 2y equals 10, minus 5, minus 5. 2y equals 5. Divided by 2. I get y equals 250. So my ordered pair is 1.25, comma 250. All right, so think about what the context solution means in the context of the problem. It wants to know the cost of things. So we're going to write it out in a complete sentence. We're going to say that soft tacos cost $1.25 and burritos cost $2.50. Okay, our last example says, since my uncle's farmland yard appeared to be overrun by dogs and chickens, I asked him how many of each he had. He responded that his dogs and chickens have a total of 148 legs and 60 heads. How many dogs and how many chickens does my uncle have? All right, so I'm going to label my variables. So X is going to equal dogs. And y is going to equal chickens. So for my first equation, I know that dogs have 4 legs and chickens have 2. So I'm going to say 4x plus 2y has to equal 148. And then the 60 heads have to be just the dogs and chickens together. So I have x plus y equals 60. So again, I'm going to use elimination method. Okay, so I'm going to multiply the bottom by 2. Okay, so my new equations are going to be 4x plus 2y equals 148, and 2x plus 2y equals 120. So I'm going to subtract. I end up with 2x, the y's cancel out, and I end up with 28. So x equals 14. So that means I have 14 dogs. Okay, and then I'm going to use the x plus y equation. So then I'm going to say 14 plus x has to equal 60. So 60 minus 14 is 46. So that's y. Y. All right, so then I can say that there are 14 dogs and 46 chickens.